Hi everybody, my name is Kai Wehner and I work as Technology Evangelist for TIBCO. Today I want to introduce to you the open source project Flogo, which TIBCO announced a few months ago, and finally in end of October 2016 it is available to the public as open source under the very permissive BSD license. Project Flogo can be used for lightweight integration for the Internet of Things and also for building ultra lightweight microservices. In this session, I want to introduce you to more details and also give a few live demos and show you the source code. If you're just interested in the live demo, you might take a look at some other videos which I published where you can just find the live demo. Here I will also talk about the concepts, architecture, and so on. So first, the key takeaways. What is Flogo? Flogo is an ultra lightweight integration framework powered by the Golang language. Flogo is open source under the permissive BSD license and also built to be easily extendable. Flogo is used to develop Internet of Things edge applications or cloud native serverless microservices, which are very lightweight and very less memory consuming. And Flogo is complementary to other integration solutions and IoT cloud platforms. That's also very important, that it's just one piece of the puzzle in a hybrid integration architecture. With these key takeaways, let's take a look at the agenda for the next hour or so. First, I want to discuss a little bit why do we need IoT edge application and what's the motivation for Flogo. Then I will give an overview and a first live demo before taking a look at different use cases for Flogo and discussing the source code in more detail. Then I will discuss the features and architecture of Flogo in more detail and also discuss how this is related to other IoT architectures of Google, Amazon, and so on. Let's begin with the motivation for Flogo. Here, first I want to define what is the Internet of Things so that we all have the same understanding of this. And the Internet of Things refers to the ever-growing network of physical objects which need connectivity and communication with each other. Therefore, it's important if you just have a few devices, that's not the Internet of Things, but you really need to connect all of them. And as we see here by a statement of Gartner, through 2018, so very soon, half of the cost of implementing IoT solutions will be spent on integration. That shows how relevant the integration part is in IoT use cases. And therefore, without integration, there is no Internet of Things because you have to integrate all the different devices. Therefore, let's take a look at this from a little bit higher picture, where we see in the middle the core business, which runs our business. This is the core infrastructure and also the core integration solutions, like the ESB on-premise or some cloud deployments which do heavyweight and powerful integration with backend systems or other cloud services. But in addition, there is also the edge. In the edge, in this case, here now all the devices, the IoT, the cars, the watches, or whatever you want to connect with your core. And that now also has to be integrated. So you need to interconnect everything. And therefore, what the analysts call this, there will be a hybrid integration platform. And the analysts are sure that that's the new default in most enterprises. There is no one piece which can integrate everything because you have to think in different locations and not just in different technologies today. So here on the left side you see some kind of, let's say, core integration like application integration on premise. And in the middle you see a lot of different options of modern integration components like application creation on a platform as a service like Cloud Foundry or Kubernetes, like iPaaS, which is hosted by a vendor, or like iSaaS, which is for the business users, for the ad hoc integrators. And on top then there API management to expose your APIs to other users. And also important in a hybrid integration architecture, as you see on the right, there is the IoT integration or edge integration or however you want to call that. And that's really for integrating edge devices at the edge. So not via the cloud or via the on-premise communication, but really directly at the edge. And that's basically the new standard that we need different components in an integration architecture. And today I want to focus on the right part with the IoT edge integration. And that's also the motivation for Flogo. Why did TIBCO create this and publish it as open source project? Because already in 2020 we will have to connect 20 billion things, and don't even think about 2025 or 2030, then we have to integrate so many more devices. And you, as I just explained, you have to run on edge devices also. Not just everything runs in the cloud or has to communicate with the cloud. That will be way too complex and too cost expensive. And therefore, this is also open source to become a broad ecosystem for all the different connectivity and integration scenarios where we want to use Flogo. Also, as a little bit of motivation why Flogo was created is that one of the key goals and differentiators of Flogo is that it's very, very lightweight. If you compare that to other engines or applications which are built with Java, like Java Drop Wizard or IBM Node-RED, which is a JavaScript Node.js based framework. And as you see here, Flogo just uses much less memory and disk space, and that's really a key differentiator to run it on edge devices, or also if you run it in the cloud and have to think about less consuming services, to pay less money to your cloud providers for each instance. And that was the motivation for Flogo. So let's now take a deeper look into Flogo, what it is. Therefore, Flogo is open source since October 2016. It's available on flogo.io, that's the Flogo website, as you can see here. And we will later also take a look at the code, which you can find on GitHub. As I said, under the permissive BSD license, so we really want to see other people use it. Even without us, without TIBCO, you can use Flogo for free and for your use cases. In summary, Project Flogo is a Golang-powered engine which is much lighter in Java and JavaScript than these kind of languages, which are used today often for IoT integration and for building microservices. It also has a very nice web designer to create your UIs and some pretty cool features which I will show you, like the auto step back web debugging. And the key really is it's open source but baked by TIBCO DNA. So really TIBCO does integration for 20 years, and we built all that with our knowledge of integration in Flogo. Here's just one screenshot, but I will also show you several live demos in this session. So this is just the web designer where you create your flows and integration and microservice scenarios. Flogo concepts from the perspective of the end user, of the developer. You see here on the left side, we have here one Flogo application which can contain one or more flows, and the flows in the end is one microservice or one integration IoT edge application. These flows have trigger which start a new flow, as you can see here on the left. This can be something like a timer or an MQTT message. And then you have several activities and conditions for content-based routing and these kind of things, which you also might know from other integration solutions. And then you also have error handling to act if something happens which is not okay with this flow here. That's basically the main concepts which you have to understand. So let's now take a first look at Flogo in the live demo. First, I want to show here you Flogo is already running on my computer in a development mode where I can develop my own flows. Here I just want to show you what is running already here for the development. So if I do a docker ps, you can see that the Flogo development environment right now uses 4 different containers. We have the Flogo web container, which uses and deploys and runs the web UI, the web designer, which is implemented with Node.js and JavaScript on the client side too. Then we have the flow service and the state service. These are running in their own containers and are managing the state and the information. So for example, this is used to handle if a running flow is failing and you have to restart it or something like this. And then we also have a Redis key value data store, a new SQL database, which stores also information. This is basically what's running in the background. And now let's go to the web browser. Here you see our Flogo website where you can go to the documentation, to the source code, and to our community for asking questions. And now I already want to go to the web IDE, which you can see here. And I will just here in the beginning for the introduction create a new flow. And this is really a hello world flow to just show you how that works in the beginning. Hello world. And I save this flow. And here I can now open it. And just for the overview here, I first create one trigger, which then starts the new flow. And you see here you can use different technologies, and in this case I want to use the timer to start just immediately with one flow. And you could do a lot of other configuration here. I do not want to do it here. I just want to use another activity here now, and in the hello world I just use the log message. And here I write hello world, and then I save this flow without any additional configuration, or I could also implement some error handling. But here let's really simply just run this very, very simple flow. It's already completed and run. You see that it runs successfully when it gets blue every activity, and in a more complex flow you can follow it to understand where it ran. And if an error is shown, then it's getting here and also becoming red. And here now in the log message you also see in the output that I now here have my hello world and also an ID of this flow instance. So you see that this flow was executed successfully. So this is where you develop your flows. You can also, of course, develop here using just the source code, which I will show you later. So you always have both options. And then we also have a configuration and administration page for Flogo. Here you can see the different engines and if they are running and the database. And you can here also take a look at the different log files if you want to do some analysis and searching for failures and errors and so on. This was the first introduction to Flogo. We will come back here later to show some more complex scenarios. But let's first talk a little bit more about use cases of Flogo. Why is Flogo so important and why is it a little bit different than other IoT integration frameworks? So the use cases for Flogo in the end we can summarize it in two different scenarios. The first one is really to build IoT edge applications. And with edge applications we really mean that you can deploy it on very small devices. We are not talking just about a Raspberry Pi here, which I would say is a little bit the legacy of IoT. So it's a still very powerful application device where you can deploy almost everything, including Java and JavaScript applications. But there are much smaller devices where you can deploy Flogo because it's so small with just a few megabytes of memory consuming. And that's really lightweight compared to the others. And you can use that in consumer scenarios, for example, device activation, or for industrial IoT scenarios like lifecycle management or performance management or diagnostics and so on. So IoT edge apps with very small lightweight services, that's the one story behind Flogo. And the other one is to build cloud-native lightweight microservices for public cloud services, for containers on a platform as a service, or even for serverless architectures. So where you pay for every kind of memory you use and for every message you send. So here it's really important to have the low consuming applications. And here it makes a key difference if you use an application which uses Java or JavaScript or something very lightweight with Flogo powered by the Go programming language. So some examples of IoT edge microservices for the consumer IoT, we see things like device registration, device diagnostics, usage billing, account management, and so on. Industrial IoT, here it's more about things like performance optimization or asset management. So we have a lot of different use cases where you can leverage Flogo to deploy integration logic at the edge on the devices or gateways. Here, one more example why Flogo makes more sense. So the typical IoT integration scenario. Here we see on the left side we have the devices and some kind of device gateway and the application in the cloud or on-premise which communicates and controls the edge devices. What's wrong with this is the connectivity from the cloud or from the on-prem server to the devices is unreliable, and there is a lot of non-trivial latency issues in all these hubs all the time. And also the network costs are adding up quickly, and they are really getting significant. If you use more and more Internet of Things devices, this gets more and more expensive also. So you have a lot of issues here. And therefore, the better solution is to use a IoT integration in different scenarios. Here you can deploy an edge microservice on the app gateway to do the local communication at the edge and not send everything to the cloud service. And you could even deploy an edge microservice logic here on the device itself. And that's only possible if you really use very lightweight microservices, for example, built with Flogo. And on the other side, in the cloud, you build your microservices, and these only communicate with the gateway sometimes, so much less than before. And therefore, you have local control, which is much more reliable. You have less traffic, which is lower TCO. And you can do edge integration and event processing here really at the edge and on site, and not sending everything to the public cloud first. That's basically a short overview about the use cases behind Flogo. So now let's take a deeper look at the source code and at the project itself. So why did we choose Golang for parts of Flogo? And we first thought about thinking using other languages like Java, node.js or C++, but all of them have different problems. So Java is way too heavyweight, and we also see some licensing risks here, so we don't know what's going on in the future with Oracle and so on. Node.js is lighter than Java, and it's also more agile, but it's not really a robust IoT language, so it's also not really the right one for us. And C, C++, which is probably the only one which is really lightweight, this is not really a modern language which is lightweight, and therefore this was also not the right one for us. And therefore we chose the Go programming language. And some reasons for that. First, Go is a modern programming language. It's getting a lot of traction these days. It's used in technologies like Docker or Kubernetes. But that's of course not the only reason. There are many more. For example, concurrency is built into the language with things like Go routines and channels. So you do not need explicit thread programming like you do in Java, for example. Memory management is much easier, also with a very modern and good garbage collector. And what I like most is that it's statically typed, in contrary to things like JavaScript or Ruby. So you have type-safe development with no surprises during runtime. And that's really a huge benefit for building IoT edge applications. But it's still partly object-oriented, so it's not all the features of object-oriented languages like Java or C#, like inheritance and so on. It has a very simple and flexible type system and uses composition instead of inheritance. So you still have some kind of instances and so on and objects, but you do not have the complex things like inheritance in Golang. And also very important, especially for IoT and edge applications, is Go's zero dependency programming model. So it's all included in a final binary file which you can deploy on the edge. And there's no dependency to external libraries, like all these dependency hells of Java and OSGI and so on, where we have many different libraries which you have to add to your project and to your final jar file in the end. And finally, the key differentiator, and that's also why Flogo is so powerful and lightweight and performant, is the speed of the Go language. With that you have ultra-fast compilation, ultra-fast startup time, and a very, very lightweight footprint. And therefore, that's really the key differentiator why using Golang for Flogo for the runtime. And so what's the difference? From another perspective, here you see different integration frameworks. All are focused on IoT integration. On the left side is Eclipse Kura, which is based on Java and OSGI. In the middle you see Node.js, which is also a cool tool for doing IoT integration. It's built on Node.js and JavaScript. And on the right side you see Flogo. And here you see really the key difference. You don't have all the different dependencies, and it's therefore much more lightweight, and it's all included in the zero dependency model. So you really just deploy one very lightweight binary to your edge app which you can run there. And though this really makes a difference why Flogo is much more lightweight than these other technologies and frameworks for IoT integration. Here is a little bit of comparison for resource requirements of IoT frameworks. You see, based on the different technologies, the disk space is already different for the minimum requirements, and this is also for the runtime. But also what's probably more important is the startup time of Flogo is very, very fast, and also the application build. So when you build your single binary which you want to deploy, that's slow with Java and more complex. Instead with Golang, that's very, very fast and easy. With JavaScript and Node.js, you do not really build binary files which you deploy. You just can run the Node.js application on a gateway, and therefore this is not really applicable to really building a binary file which you can then deploy to a very lightweight device. So again, we are not just talking about Raspberry Pis where you can run all of these, but really about the smaller devices, which we will see more and more in IoT scenarios. With that, let's talk a little bit more about Flogo. Here you see the screenshot of the repository, which is published on GitHub. Once again, it's published under the very permissive BSD license, so we really want you to use the code, and even without TIBCO, you can use it. You can, of course, contribute it. We would be happy to see that. And here you see 4 different projects which are available right now. And this is the Flogo lib. This is the core libraries and the core engine of Flogo. This is what in the end runs at the edge devices. Then we have the Flogo services. This is baking services which are used by the core engine, and this is for flow and state management. So for example, if a flow fails or if a device is not available and you have to retry it or reroute to another device, then this kind of state can be stored in the Flogo services. We have the Flogo contrib project. This includes all the extensions like triggers and activities. So for example, the connectivity to REST or MQTT, or some components for filtering or for the transformation. That's the stuff which is stored here. And this is probably the one which will be much more increased number in the future when we add, and also the community can add more and more different contributions. And then we have the Flogo CLI, which is the command line interface to build Flogo applications. This can be used for automation, for doing things like continuous integration, continuous delivery, and DevOps style development. Though this is basically the open source project. And I also want to highlight that the web UI, which I will also show you or already showed you, will be available very soon. So I'm recording this in October 2016, and probably when you watch this video, we have already published the web designer for you for free download to use it in combination with these projects for the runtime. Okay, let's take a short look at the source code too. For that, I switched to Light IDE, which is a development environment which is relatively lightweight and not as powerful as Eclipse or something like this, but it has also very nice Go programming language support, and therefore I like to use it here. I already imported the 4 Flogo projects, and just want to take a short look with you. You can dig into that and take a look at more details if you want. It's absolutely possible, and you can change it, use it, do with it whatever you want. Flogo lib, as I said, is the core engine, the core library. Here you see things like the actions implemented, and then also all the different data types. So Flogo only uses simple data types, but it can also be extended. And you see the core engine, for example, with its runners. So you can define how you want to run your flows, either directly or pooled or with worker threads in the end. So this is really the implementation of the core engine of Flogo. It's not really that much code, but it's really the core process engine. And then second, we have the Flogo services. These are the flow state and the flow store service, which will manage information about devices, which you would use as baking service for the core engine if you want to store information or get back information about failing devices or retrying or restarting, rerouting, and these kind of use cases. Then, as I said, this one probably the most interesting for many of you in the beginning, the Flogo contrib, where you have all the different activities, like you can see here, the error handler, the logger, the reply component, and so on. And we have all the triggers, like for CoaP, for MQTT, or the timer, which I used in the Hello World example in the beginning. And if you take a look at these projects in a few months, I'm pretty sure this number of activities and triggers is much higher than now in the beginning. Because also remember, and if you see that in GitHub also, right now this is really the first developer release, though this is really a technical preview right now and will be improved a lot in the next weeks and months. Let's take a look at one example, at the REST activity. And here you see this is typical Golang code, and we leverage the standard Golang libraries like the I/O and the network communication libraries to implement, in this case, the REST activity. Then we use constants and variables, we define types and structures, we use all the different Golang features to implement our, in this case, activity for REST service implementations. And as I said, take a look at this and also develop your own stuff if you want. And finally, the Flogo command line interface. This is also implemented in Go. Here you see, for example, the different commands which you can use in the CLI, like adding a new flow or build the complete thing. And that's basically what you use in the command line, and here is the implementation for it. That was a very short overview about the source code which is available on GitHub, and I really invite you to take a deeper look into that by yourself, or to come back to us with questions in our TIPCO community if you want to know more about that. Let's now talk a little bit more about the architecture and features behind Flogo. The Flogo architecture, you see here we have in the middle the application, which is waiting with its triggers for doing new actions. Therefore, Flogo, like most of these IoT applications and gateways, is event-based. And then when there happens an action, an event, then you can use your flow or state service to execute the different flows here. And one flow, as we have seen, then has different activities which are executed in a different way depending on the variables and on the circumstances which are available at runtime. And also here everywhere you can use your own code. So for example, you can define your own actions. Here you see the class or the source file in the GitHub repository to implement your own actions. But you can of course also implement your own activities and your own triggers and so on. This is a high-level overview about the architecture, and just to highlight here one more again, Flogo is a process engine. That's very important to understand. So that means that it's used to wire together hardware devices, APIs, and online services, and it's used to integrate and orchestrate different devices and microservices, to leverage enterprise integration patterns like transformation, filter, routing, and so on, and also do things like error handling, retrying, rerouting, waiting, resuming. And that's these kind of things which a process engine does. And that in combination with state management, we are the state services and flow services, is used for the use cases we discussed in the beginning for consumer IoT and also for industrial IoT use cases. The key difference here again is that it's a process engine and not just a data flow pipeline. If you want to understand more about all that, so the difference to other data flow pipelines like Apache NiFi or like many other open source frameworks which are available for doing things like ETL and really putting data from the source to the target, and this with a high performance, high throughput. That's just a data flow pipeline. It's for different use cases. And I compared that to process engines like Flogo and also to others like Eclipse Kura and IBM Node-RED in another YouTube video which is uploaded. So just search for that and you can see a much more detailed explanation how a process engine is different from that. And on the right side, you see again a Flogo application. Therefore, it has the data model and the flow model and the triggers and activities. But the key then really is the flows, which leverage all of these features and not just a data pipeline, but much, much more. So some more characteristics of Flogo. Flogo, once again, important to highlight, it's open source under the permissive BSD license. It's an ultralight footprint because it's powered by Go for the runtime engine for edge devices. This is important for both disk and memory consumption. with its zero dependency model, as I already discussed, and it can be run on a variety of platforms. And as I said, a Raspberry Pi is more one of the bigger ones, so we are all really talking about smaller ones too, so very small edge devices. Connectivity to IoT technologies like MQTT, CoaP or REST, and many more will follow in the future. And it's really highly optimized for unreliable IoT edge environments. Flogo right now is for developers, for integration specialists. So you have to know something about coding, but with the web UI, even as a citizen integrator, so with less technical knowledge, you can still use Flogo to develop your own integration scenarios with the visual coding in the web UI and also do testing and debugging and so on. It's really extendable, so we want you to extend it to use it for your use cases via the SDK and all the APIs, and also you can change the source code. It also has some innovating features which you do not see in the other components which can be used for IoT integration, like the step back debugger, which I can show you in a minute in the live demo. And with that, you can also do things like remote operations and analysis directly on the devices. So if you know IoT development, that's also a complex thing with edge and IoT debugging, and that's much, much easier this way. And there are other innovative features I will talk about later. So the web step debugger, that's really one cool thing. So it's here, as I said, web native, that's important. So really you never go away from your web IDE, from your development IDE. It's a little bit like you do debugging in an IDE like Eclipse on your operating system, but it's really just in the web IDE and all in memory with the state services and so on. And you can interactively design and debug your flow, and also leverage this for simulating sensor events and for changing data or configuration without rebuilding or restarting the flow. And that's pretty cool. And you then could even leverage that to do some things like remote ops debugging. So really connect to a flow which is running on an edge device and debug it there. And that's really one of the innovative features of Flogo right now. Let's take a look at some more advanced use cases to also see this stuff in action. Therefore, we go back to our web IDE and I have a few more projects imported here already. So for example, I have a flow which uses MQTT as connection. This is just to show you it doesn't matter what technology you want to use as trigger or in activities, you just configure it here. And the other things like you combine it with all the other activities. That's always the same. And for that, you can always use the transform feature. So no matter which triggers and activity you use, you always use the same transform visualization to map from your input to your output. And so in this example, we have no input here, and then therefore it doesn't make sense to map it to output. So I will show you an example in a minute where it makes more sense. But this is basically what you use all the time: transformation, and then also branches to do things like content-based routing and to do condition-based flow routing. So let's take a look at a more complex example, a weather service. In this case, I built a REST service. So here, a service consumer has to execute this, to consume it via the port 888, and we do a get operation with this path and the parameters as I have configured here. And then when this happens, we log the message, and then we do an invoke REST call. Here we use an external weather service, which is for free, where we can get the information about the weather in a specific city. We get this as response and log it again, and then also we use the reply to trigger activity to send it back to our service consumer, the weather information in this case. And if we take a look, for example, now at the transformation at the log message, here you can see on the left side that we can get all the information from the different previous activities. So not just from the last one, so not just from this one, but from all the other ones we can get the information here. So we can also do more complex mappings and aggregations and filtering and so on. And in this case, what I want to do here, I want to get from this REST invoke of the weather service the result. And to be more specific of the result, I want to receive the the message which we get here. So here we receive the message and we want to map it to our outbound message of the logging component. And then we also do the same for the reply to trigger. And I did not implement any error handling here. We could leverage all the activities also for doing some error handling here. Let's now run this from the trigger. Here I just have to run the trigger, and then what it does in the background, it compiles the Golang code, and then it also executes the flow. And here you see it's blue again, so it was successfully. And then we can also see here that all the output is there. So for example, here we see the output from the weather REST service, which is, in this case, it's Erlangen, it's my hometown in Germany, and the weather there right now is 10 degrees Celsius. And this is the way you can then run and debug this. And then when it's done, you can also export it. And there are different things what you can do. You can either export the flows in a JSON structure to share it, for example, via Subversion with the version control management, or with other developers and so on. So the flows here are really just exported as JSON files. So you can also leverage this in any other kind of automatic tooling, for example, for quality assurance of the code and so on. And then you can also build it, and that's also a key. You can build it for many different systems. For example, I already built this weather service for the OS X for my Mac operating system, so that I only have one single binary file which includes all the code with 0 dependencies. So here you can see I'm now here in my Flogo builds directory, and for example I have here the simple weather service without 0 dependency to other things. Everything is included here in this weather service so that I can execute it. In this case for testing just on my Mac operating system, but you could also do it of course on any kind of very small edge device. And now take a look, if I press the button, how quickly it starts the application. It's very, very fast, and now the REST service is running here and waiting for me to call it. It's exactly this weather service here. And so I can call it in the web browser, for example, or using curl or another application. In this case, what I'm doing, I'm just returning the flow ID here. So, but you see that it works. And if we go back to our terminal here, we can also see that the flow was executed, and that we can see here our weather information for Erlangen with the temperature 10 degrees Celsius. So this weather service is running perfectly, and we could also deploy it on any edge device without any kind of dependencies to other libraries or so. With that, let's take a look at an even more complex example. So what I also have here is the try to find pet flow. This one leverages another REST service, and I use this by intention so that you can also try this out by yourself. For REST, we usually use Swagger, which is the more or less de facto standard for defining REST interfaces and for documenting them and testing them. So Swagger is used by many companies like Red Hat, IBM, or TIBCO, and as I said, it's more or less the de facto standard. And here it's a free REST service pet store from Swagger. Everybody can use it, and we want to use the get pet via ID service here. And you can try it out here in the web UI of Swagger. You can try out and search for the ID 222. And here we see it's returning a pet with the name 222 UX Doggy, which we created before here. So everybody can play around with this REST service. And now let's go to our pet service. This one is starting again with a REST request and then doing some logging, and here is now the key logic to query for a pet. And what we do, we can search also for this pet with the ID 222 and then make a decision, a condition-based decision. If the code which is returned is 1, which means in this Swagger implementation that no pet is existing, then we will create a new pet by using this API, using a post method. Or if it's already existing, which is the code 222 in this Swagger API, then we use the delete method and use this REST service to delete the pet. And let's now simply run it. And what's happening here now? You see the flow is going on, and you see it's going this direction because the pad is already existing and therefore it deleted it. As you can see here successfully. And we can also double check that in our Swagger user interface. Let's try to call this again. And now we see that this pad is not existing at the moment because we just deleted it. Therefore, what we can do now, and this is now also using this step back debugger, we do not have to go back to the complete beginning of the application. We can, for example, just start here at query a pad and run from this tile. And now what we can do is run that from tile here, and now you see the flow is starting here, not from the beginning, and it's going this direction because now the pad exists, not, and now we created it. So you see now the pad was created successfully again. We can double check here in our REST API by trying it out again. And here you see now we created it again. And here, this is one of the huge benefits with this. You can go back and forward, and for example, you can also do changes here. For example, change the configuration and then run it again here. And this is what we meant with the step back debugger. You can step forward and back and change things and run just parts of this flow again. And that's a really powerful feature to do agile development. And with that, you could even do some kind of remote development and remote ops on remote edge devices where a Flogo app is deployed on. And though that's really a pretty cool feature which I wanted to highlight here in the end of that. So that's my overview of the Flogo live demo, so that you have hopefully an overview about that. If not, come back to me with questions directly or to the TIBCO community with more questions. And now, just a little bit as outlook here. What we will also deliver next year is a conversational user experience with design bots. So we already have this in beta, and it's pretty cool. It's simply another kind of development and showing some more innovation by creating a design bot which you talk to instead of writing code in a command line or via the web UI. This will come in 2017, and it's just a pretty cool outlook to that feature. After now, I have showed you Flogo in a lot of detail with concepts, source code, and live UI. Let's finally talk about how is this related to other IoT reference architectures. Because as we discussed in the beginning, Flogo is just one part of hybrid integration architecture. Therefore, what I want to do is I want to show you a few different reference architectures from different cloud vendors. For example, Intel IoT reference architecture. Here you see the things on the left and the network in the middle, the cloud on the right. And potential Flogo use cases include all we discussed, like event-driven flows and rules, device lifecycle management, and you can deploy that on the gateways, but also on the things, of course, if it's some lightweight edge applications. If you take a look at the Amazon IoT reference architectures, so Amazon has a lot of cool services in their public cloud for authentication and authorization, a device gateway, rules engine, and then you also need to do something at the edge again, because the public cloud starts, of course, in the cloud interface at Amazon, and you can leverage the AWS IoT device SDK, and you can also build edge applications with Flogo here and combine it perfectly with the Amazon application architecture here. For Google IoT, it's pretty similar. So Google has a lot of cool features for IoT, and here again we could use Flogo edge apps on the gateway or even on some constrained devices. A little bit more detail at one from IBM's OpenWhisk. OpenWhisk is an open source serverless architecture and software. You can use it on Bluemix, on IBM's cloud service, but also on other devices. It's open source and free, and it's serverless. That means that you really can bill really by usage, by memory and by disk usage. And this, I think serverless is really the new cloud native, because you do not pay by containers or by instances of your Windows or Linux machines, but just by the service requests and usage of memory. And for that, I really like to discuss how you could leverage Flogo here, because Flogo is so relevant if you really need to take care about thinking about consuming memory and disk space and so on. And therefore, of course, you can also run something else here like Java applications or JavaScript, but you can also build ultra lightweight serverless Flogo applications and deploy them to OpenWhisk in a serverless architecture. And in addition, of course, you can use it in the Edge gateway, which then can communicate with OpenWhisk services, which could, of course, also be non-Flogo services, which you can connect to here. And of course, also you can deploy Flogo in an Edge application. So the cool thing here is then you can leverage Flogo in different parts in this IoT and service architecture. And that's really a pretty cool thing, I think, and it makes a lot of sense because you can also use other things here like Node.js or Eclipse Kura or these kind of IoT integration frameworks. But with Flogo, it's all about using less memory and less disk space and be performant with that. That's really the key differentiator, I would say. And with that, again, to the outlook, what we are also building right now, and you might see that in a few weeks or months already, is that we also want to deploy Flogo via nano services, what we call it, on microcontrollers. So here we are really targeting microcontrollers like the ARM M0. And if you know that, here that's really about very, very small devices. Though this is not a Raspberry Pi-like thing, but this is small devices. And here you might not be able to deploy a complete Flogo application, but only parts of it because it's so small. And then you can combine it with a more powerful Flogo app. But that's really what we're targeting now, that you can also deploy parts of the Flogo engine even on a microcontroller. And then you see what we mean with really small devices and not just the Raspberry Pi-like devices. So in summary, let's end the session with the key takeaways. Flogo is an ultra lightweight integration framework powered by Golang. It is open source under the very permissive BSD license and easily extendable. And it is used to develop IoT edge applications on very small devices, or if you want to use very low consuming devices regarding memory and disk space and so on. And you can, of course, also use this to build cloud native microservices for things like Cloud Foundry or Kubernetes, or even serverless microservices. And also very important, in the meantime, we are talking about hybrid integration architectures. Therefore, Flogo is very complementary to other IoT integration solutions, to other cloud platforms, and even to things like Node.js and other IoT integration frameworks. I hope this was a good overview about Flogo, and if you have feedback for that, questions, please take a look at our source code at the project, ask questions to our community, and also give me feedback here on the video or contact me directly. We are happy to get your feedback about Flogo. Thanks a lot for watching this video.